I'm going to explain target 5a. So pretty much I have to explain how to find an inverse function from a graph and a table. So from a table, it's pretty easy. What you're going to do is just switch the x and y value. So I'll do that real quick. Okay, so that's all you have to do. And now this is the inverse of this. Part 2 is with the graph. So you're going to take each point. So this one's -1, 1. And do the same thing. You're going to switch the x and y. So now it's going to be +1, -1. And the next point is going to be +2, -2. And the next point is going to be 3, -1. So it's going to be 3, -1. Next, you're going to draw the line f of x equals x. So it's just going to be just like this. And then all these points, when you do this, they should all make a right angle with this line. They all must be bisected by the line x equals f of x, and they must have opposite reciprocal slopes. Okay, so target 5b is explain how to determine if an inverse function exists from a graph, table, and equation. So we'll start off with the equation. So I have two types of equations up here. I have exponential and linear. So linear functions, they will always have an inverse. But exponential functions, in order for them to have an inverse, you have to limit the x-axis. Now for the graphs. To tell if they have an inverse or not, you can do something called the horizontal line test. So you draw a horizontal line, and if it intersects more than once, the graph doesn't have an inverse. So on these two, the first graph only intersects once, which means that it will have an inverse, and the second graph intersects twice. So it'll only have an inverse if you restrict the x value. Okay, now for tables. So in order for the table to have an inverse, how you can tell is for every one x value, there has to be exactly one y value. So in these two tables, in this one, for every x value, there's exactly one y value, and it doesn't repeat. But in this one, when x is 2, g of x is -3, and when x is 4, g of x is -3. Therefore, there is no inverse. Target 6a is finding the inverse function of this linear function. Okay, so what you're going to do first is take f of x, turn it into y. They're basically the same thing. So your new equation is y equals 3x minus 5. So first you're going to switch the x and y. So your new equation is x equals 3y minus 5. So after you do this, you can add 5 to both sides. You're pretty much just solving. So you get x plus 5 equals 3y. Next, you're going to divide both sides by 3 to get rid of this 3. So you get y equals x plus 5 over 3. So your last step is to change y equals into f inverse of x equals x plus 5 over 3. Okay, 6b, you're going to find the inverse of this function, and this function is exponential. So you're going to start off doing changing g of x to y, because remember, they equal the same thing. They're the same thing. So now you have y equals 11 times 2 to the power of x. After this, you're going to switch x and y. So x equals 11 times 2 to the power of y. After you do this, you're going to divide both sides by 11 to get rid of that 11. And you get x over 11 equals 2 power of y. After you do this, so now you have to solve for y, you have to get the exponents equal to each other. But first, to do that, you have to get the bases equal to each other. So this is now going to be 2 and log 2. So now that we have this, it's equal to 2y. And since our bases are now the same, all we have to do is look at the exponents. So we have equals y. Then remember our last step is to turn y back into g inverse of x equals so that's your final answer. Okay, for 6c, we have to find the inverse of this quadratic function. We're going to start off by changing this equation to a y equals. So y equals x to the power of 2 plus 2x minus 3. After you've done this, you're going to switch x and y. So you're going to get x equals y to the power of 2 plus 2y minus 3. So now you got to put certain parts in different parentheses. So your new equation is going to be x equals this is going to be your new equation. So to get this number, you're going to take this and divide it by 2. So 2 divided by 2 equals 1. And you're going to multiply whatever answer you get here by itself. So pretty much squaring it. So 1 squared is 1. So it goes in here. It's 1. And now, since you've added 1 to the inside of the parentheses, you have to subtract 1 from the outside of the parentheses just to keep everything equal. So now that we have this, we can now simplify our equation. So and after this, we can simplify it even more. So our new equation is going to be y plus 1 squared, or to the power of 2, minus 4 equals x. Okay, so we've moved this equation up here just because I ran out of room. So first step is to add 4 to both sides. So your new equation is going to be x plus 4 equals. Okay, so after this, you got to get rid of this 2. So to do that, you're going to take the square root of both sides. So that's going to end up being x plus 4 square root y plus 1. So after you've done this, you have to subtract 1 from each side to get rid of this. So now you're going to get x plus 4 being squared, and then you have to have the minus 1 on the outside of that equals y. Then the very last step is to turn y into h inverse of x. So new equation, bring it right here. H inverse x equals the square root of x plus 4, then minus 1, not the square root.